Hi everyone, welcome to our class today on constructions. Constructions is just a little mini unit that is following unit 5. In this unit, you're going to need your compass and straight edge, which K-12 should have sent to you when you enrolled in our course. If you did not get those tools, that is perfectly okay because I've also provided you with the virtual tools. You may like the virtual tools better anyway, and I recommend that you kind of practice with both, especially because on the SOL, you're only going to be given the virtual tools. And the virtual compass is actually a bird's eye view of the compass that you'll be using today. So the compass that we're seeing looks like there we go. It looks like what you see on the screen here, this tool. And a straight edge is anything that you can use to draw a straight line. So if I was using like pencil and paper, I might use a ruler for a straight edge so that I can draw a straight line. Or I might use the edge of a protractor so I could draw a straight line. The only purpose of those is to draw a straight line. It's not to be measuring anything. So if you find yourself measuring something at any point, you're not doing it correctly based on the construction's steps. So there should be no measuring. What we're going to use on our screen is actually just a straight line. Okay, so we have a few constructions that we're responsible for in our curriculum. And the first one is, let's bring you back here, is creating a segment bisector. Okay, so on your notes, every page here looks very similar. You see that? What's different on each one is the name of the construction that we're using. So this is going to be a construction of a segment bisector. I have the link to the virtual tools for you here. And then I also have a Math Open Ref link for you. And if you click on the Math Open Ref link, I'm going to click on it now. It's going to take you to mathopenref.com. And the segment bisector is actually a perpendicular bisector. So if you want to watch the steps, you can click next for each one and it'll take you through the steps in words and visually with the compass. If you want to see it go through the steps over and over again, you can click run and it'll just keep doing the steps over and over. I will tell you the best way to get good at constructions is to practice them. Okay, so watching me do it once or twice, it probably isn't just going to suffice. You're going to want to practice these a few times to make sure you know the steps. Because on an assessment, you have to be able to identify the construction that's happening in the picture. You might be asked to put the steps in order. You might be asked to pick the next step in the sequence of steps that you see. So if you can do the construction from start to finish, any of those things should come easily. So if you can do the construction, I think you can answer just about any assessment question that is thrown your way. So the first construction that they're going to ask us to do is a segment bisector. Now the downfall with the virtual tools here is you're not given the actual segment. So you have to draw yourself a segment. So you're going to give yourself a segment, any old segment you want. I shouldn't have put it there. I'll put it down here. Okay, so give yourself a segment and then your segment's going to have endpoints. So we'll say here. And here are the endpoints. You can use a little pencil tool to give yourself endpoints. All right. So to construct the bisector of this, you're going to take your compass and you're going to put the pointy part of your compass on one endpoint. And you're going to open your compass so that's open at least more than half of this segment. So I wouldn't put it here. I would go at least more than half. And my personal preference is actually just to put it on the other endpoint. Then you're going to lock your compass. And if you're using a handheld tool, that just means you're going to pinch your compass really tight because you don't want it to move. If it moves, it's going to mess up your construction. And what you're going to do is you're going to make an arc above your segment and below your segment. So you're going to move your compass. See how it's not moving because I locked it? That's really good. If you're using a handheld tool, it might help to move the paper instead of the compass. Some students find that easier. On the virtual tools, to make the mark, you want to go to the top of the compass. Notice that when I put my mouse over it, it becomes these like circly arrows. When you click on that black part, it's actually going to make an arc. Like it'll make the pencil make a marking. And then you're going to make an arc below the segment also. It's going out of control. There we go. If it's a little bit more challenging to make two different arcs, especially if you're using the handheld paper or handheld compass, you're welcome to just make one big arc. That's okay too. Once you've done that, then you're going to take your pointy part of your compass. Don't let your compass move. Like don't let the pencil and the point change its distance. Take that pointy part of your compass and move it over here to the other end point, and then repeat the process of making an arc above and below. And again, if you just want to make one big arc, you're welcome to do that too. Okay, so there's what it would look like. If you made one big arc, it would look like this. Now what we've done is we've created these intersections here and here. We're going to take our straight edge and connect those intersections. That point where that red line intersected the original segment is the bisector. Right here. Here's the segment bisector. So this piece and this piece are now congruent. You're welcome to rewatch these steps. You can go back in the play pause it and watch it again, or you can watch it on Math Open Ref. Whatever works best for you. The best way, again, to get to be able to do these is to practice. So do it yourself. Go step by step with the video. Go step by step with my video, whatever works best for you to make sure that you know the steps so you can identify them on any assessment, and you could identify the step that would come next. All right. So that was a bisector. The next one, we need to create a congruent segment. Okay, so you're going to go to your tools. I'm going to use the virtual tools again, of course. And you need to give yourself a segment to make congruent since there isn't one on your screen. So here's a segment. This looks nice. You might want to give it some endpoints. Okay. And now I'm going to construct a segment that is congruent to this. I am not going to measure this with a ruler and then create a segment that's the same length. That is not what we're going to do. Instead, we're going to follow the steps of constructions. You're going to make yourself a ray. And I like to make it kind of obnoxiously longer than the original one, just so I know that it's definitely going to be long enough. Give yourself an endpoint. Here it is. I'm going to take my compass, and you're going to put the point of your compass on one end point of your given segment and your pencil on the other point and lock it. By doing this, you have captured the distance from endpoint to endpoint between the tip of your compass and the tip of the pencil. And now what you can do is come down to the ray that we drew here in red, put the pointy part of the compass on the endpoint, and use your pencil to construct this arc that goes through it. So now the distance from the red endpoint to this red intersection is exactly the same distance as the endpoint to endpoint was on the original segment. So now we can give ourselves a point right here. And this distance from endpoint to intersection is the same distance as endpoint to endpoint was up here. So I can say that this distance, this segment that I just put in black ink, is exactly the same length as my blue segment. So that was a congruent segment. How about a congruent angle? So you're going to have to give yourself an angle. And you can give yourself whatever kind of angle you want. If you want it to be an obtuse angle, you want an acute angle, whatever kind of angle you want. I'm going to do obtuse. You're welcome to do acute. You're welcome to practice both ways. First step, give yourself a ray. Here we go. And then what you're going to do is take your compass, oops, put the end point on the vertex, and you're going to construct an arc that goes through both rays of the angle. So here we go. And the question sometimes happens, what happens if they don't actually intersect? See how I kind of missed right here? Well, that just means that you need to make your ray longer. And that's okay. That's why we have that straight edge. Just take your straight edge and make it a little bit longer. There we go. All right, so now I have an intersection here and here. Okay. What we're going to do is we're going to take our compass and we're going to put its point on the vertex of the original angle. And we're going to open up our compass so that it is the same distance from the point to one of those intersections. And it doesn't matter, you could pick this one up here, or if it's easier, you could put your point over here. They're going to be the same. Lock your compass or hold it tight so it doesn't move, and then bring the pointy part of your compass to the end point of the ray you drew yourself and make an arc. There we go. So now what we've done is, you can follow my pencil here, or my mouse. From this end point to this intersection here is exactly the same distance as this end point to this intersection. Those are exactly the same. So now I need to figure out where over here is that other intersection going to occur. So you're going to take your compass and you're going to capture the distance from intersection to intersection. So you're going to have to unlock your compass or let it move. And you're going to put the point on one intersection and the pencil on the other intersection. Unlock your compass or hold it tightly if you're using the handheld tools. Bring the point to the intersection we've created here, and then let your pencil make an arc. So now we have an intersection right here. You're going to take your straight edge and connect the end point of the red ray and this intersection. And now my red angle here is exactly the same as the original angle that we drew for ourselves. This would work for an acute angle also. So if you want to try drawing yourself an acute angle and practicing, you're welcome to do that. And if you need to watch the recording again to do step by step, that's perfectly acceptable. Or if you would like to watch the Math Open Ref video on copying an angle, it will show you the same steps. And they use an acute angle there if you want to see the acute angle. It's the same steps. You can arc through both rays of the given angle, make the same size arc on your new ray. Capture the distance between these two intersections. Move your compass to copy that distance. And now you can connect that intersection to the vertex of your new angle. And there you go. Okay. The next construction is going to be an angle bisector. So on your paper or on your virtual tools, you're again going to have to give yourself an angle. So it can be an acute angle, an obtuse angle, whatever angle you want. Let's go acute this time. And what we're going to do is we're going to construct the angle bisector. So what you want to do is take your compass. You can let it move. Put the end point on the vertex of your angle. And it doesn't really matter how big you open it up. I wouldn't be like crazy. Here looks good. Lock your compass and make an arc that goes through both rays. Boom, there it is. Now you could let your compass move here if you wanted. I tend to keep it exactly the same. You're going to move the point of your compass so it's on one of those new intersections that you just made, and you're going to make an arc on the interior of your angle. Keeping the compass exactly the same, put your endpoint on the other intersection and then make another arc. And if they don't intersect, that just means you didn't make the first arc long enough. So you would have to come back over here and make it bigger if you had to, if they didn't intersect. So now what you've done is that intersection you just made right there. When you connect it to this vertex, it is now cutting the original angle into two congruent pieces. So this arc and this arc are now exactly the same size. Or this arc right here is half of the original arc. Again, if you want to watch that again, you're welcome to go back in the video and watch this again, or click on the link in the PowerPoint and it will take you right to the video in Math Open Ref showing you the steps. The next construction is a perpendicular line through a point not on a line. So perpendicular through a point not on a line, it's important to know because the next one, the point will be on the line, just so you know. Okay, so you're going to have to give yourself a line and a point not on that line. So a line, there you go, just any old line, and then give yourself a point not on it. I wouldn't make it in the middle. I would make it like over here, just so that you don't get confused with perpendicular bisector. So we're going to construct a line that goes through that point and is perpendicular to the line that we just drew. Okay. There we go. All right. So what you're going to do is you are going to take your compass. You're going to put the point of your compass on that exterior point. You're going to take this, put your point here on this out point not on a line, and you're going to bring your compass down and make two arcs that go through the given line. So here's one. Oh, come on, come over here. There we go. And here's two. And now if you didn't make your line long enough, or if it doesn't intersect exactly, just use your straight edge to make your line longer, and that's okay. This happens a lot, especially using handheld tools. You might have to make the line longer, and that's okay. So now we have these two intersections that we just created, here and here. We've created this segment. And this point right here is now the same distance from each intersection. So now what we can do is put our compass point on this intersection and make a mark below. Bring your compass point to this intersection, make another arc below. And now we can connect that outside point to this intersection we just created. So that point that wasn't on the line is now on this red line, which is making a right angle with the original given segment. And that point is not on the line. So here we have a perpendicular line through a point that wasn't on the original given line. You need to be able to identify the steps, and you need to be able to identify the construction given the steps. It's also a really good idea to be able to do the steps, so that way, if you're asked to put them in an order or in a sequence, you know exactly what order to put them in. All right, the next construction is through a point that is on the line. So the only difference here is this point that's going to be given to us is going to be on the line. So you're going to have to give yourself a line. Give yourself a line. There you go. Give yourself a point on the line. Again, don't pick a point in the middle because you don't want to get this confused with the perpendicular bisector. Pick a point that's clearly not in the middle. All right, and now what we're going to do is create a perpendicular line. It's going to be perpendicular to this given line, and it's going to go through this point. So there will be a line here that is perpendicular. You're going to take your compass and put your point on your given point here, and you're going to make some arcs on either side, and it doesn't matter how big your compass is. I would not be like crazy and be like out here, and I wouldn't be super teeny tiny in here. This looks good. Keep your compass, lock it so it stays the same. Make an arc out here and over here. Now we want intersections. I have a nice pretty intersection right here, but not over here. So I'm going to take my straight edge and just make my given line a little bit longer. And now what I've done is I've created this segment and I forced this point to be in the middle. So now we're going to use our bisector steps. You can take your compass, put it on one intersection, open up your pencil so that's at least more than half. I'm going to run out of room here if I try to move this around. So I'm just going to bring this in a little. It has to be at least more than half. So past the red dot, but before the intersection. So anywhere in here I can put my pencil. I'm going to put it here. You can lock your pencil, and then you're going to make an arc above and an arc below. Whoop. Okay. All right, fine. All the way down here. And then you're going to move your point to the other intersection that we created and do the same thing. An arc below and an arc above. And if it helps to just make one big arc and one sweeping motion, that's fine too. And then you're going to connect your two intersections here to here. And that line is now perpendicular to your given line, and it goes through that point that was originally on the line. So this is how you would construct a perpendicular line to a point on a line. Here we have one more. Right, the last construction for today is parallel lines using a compass and straight edge. We're going to construct some parallel lines. Okay, and there's a link for Math Open Ref here if you would like to watch that video, or you're welcome to watch this one as many times as you need to. Okay, so you're gonna need a line. So give yourself a line. This looks nice. And give yourself a point. Oh, this looks good. And what we're going to do is we're going to construct a line that is parallel to this line, and it goes through this point. So there's going to be a line up here that goes through this point, and it's going to be parallel to this one. So the first thing that you're going to want to do is take your straight edge and make a line that goes through the given line, through the point, and then up a little ways. And now we're going to use what's called the angle copy method. I'm going to copy this angle right here to here. These would be corresponding angles. And if I can force my corresponding angles to be congruent, then that means the lines are parallel. That's the converse of corresponding angles. Of course, it's going to do all that. Okay, so I'm going to copy this angle here, put it here, forcing my corresponding angles to be congruent, which would force my lines to be parallel. Okay, so let's copy this angle. So we're going to put our point on the vertex. I would not open up my pencil to go past that point right there. So anywhere in here would be okay, but if you open it up here, then your picture is going to start to get messy. You can still do it, it just gets kind of messy. So I'm going to keep my point down here. I'm going to lock my compass and I'm going to make an arc that goes through both rays. And then I'm going to bring my point up to this point. This will be the vertex of my new angle, and I'm going to make an arc here. Whoa, and I didn't want it to go all the way over there. I want it to be here. There we go. And now I'm going to capture the distance between this intersection here and this intersection. Locking my compass, I'm going to take the point of my compass up to this intersection and make an arc. Boom. Okay, and then I'm going to take my straight edge and I'm going to connect that point to this intersection and make a straight line. And now because this angle, it's not working, is congruent to this angle, that means that these lines have to be parallel by the converse of corresponding angles theorem. So I forced the corresponding angles to be congruent, making these lines parallel. If your compass moved even the tiniest bit on a handheld, your lines might not look parallel. And that happens to me too when I'm using a handheld compass. If it moves even the tiniest bit, it does throw this off and your lines don't look parallel. But if you did every single step correctly, that's okay. And you can practice using it. You might need to tighten up your compass if you have a cheap compass. Sometimes that happens, they get loose. But this is the one that students need to practice, I think, the most, just because it has, I think, the most steps. So you are welcome to practice this as many times as you need to. I know that this unit is weird compared to any other math unit you've ever done it before in your life. Right? You're actually using a tool to make measurements and create marks on your paper without using the ruler. So it takes practice. It really does. I highly recommend going through each one. Okay, go through each one. Maybe watch the open ref document, practice it, and practice it as many times as you need to. And do that for each one. We're going to do a few more constructions on Wednesday in class, not this many. And if you need me to review any of these at the end of class, I'm happy to do that for you also. Okay, so I hope that this was beneficial to you. If you have questions, you're welcome to reach out to me. And the number one question I get in this unit is, can I have more practice? Honestly, what I will tell you is draw a line on your paper and practice doing whatever construction you're doing. There's no secret or other problems to do. Just draw a line on your paper and practice the construction that you need help with. Follow the steps from Math Open Ref, follow the steps from my video. If you want me to print you out the steps in words, I can happily send you that. But it's really just practicing it over and over again until you know the steps. The steps aren't going to change. The constructions aren't going to change. These are the constructions you need to know. So just practicing them is the best way to get good at them. All right. I hope you all have a wonderful day, and I look forward to seeing you on Wednesday.